Hi everyone, today's lesson is on trigonometric ratios and their inverses, sine, cosine, tangent, and their inverses, which are arc sine, arc cosine, and arc tangent. So before we get started with that, I want to review the special right triangles that we went over the other day. So just to get started with that and reviewing some special right triangles, what we have here is one of our special right triangles. This is a 45, 45, 90, and we have x, x, x root 2. Remember, this is going to be across from the right angle, the x root 2. So basically, if I had the number 5 here, that would be 5. This number here would be 5 root 2. If I had this number was 6, this would be 6. This would be 6 root 2. If this number was 4 root 2, then these numbers would be 4 and 4. Because remember, it is an isosceles right triangle, which two sides are congruent. The problem comes in when this number here is not an x root 2. Let's say it's a whole number, such as 8. What you would do is you have a choice for doing two different things. Number one, you can say, I don't know what the sides are, so I'm going to call them x and x. And if that's the case, I'm going to use Pythagorean Theorem. I'm going to say x squared plus x squared is equal to 8 squared. And then I'm going to say, well, that's 2x squared, which equals 64. I'm going to divide by 2. I'm going to get x squared equals 32. I'm going to get x equals the square root of 32. And I'm going to break that down into little roots, which are square root of 16 times the square root of 2. So x is equal to 4 root 2. Okay. Now, there is a little trick here with this being a 45, 45, 90, in that we're going to take this number here. We're going to take that number, we're going to divide by 2 and multiply by root 2. That's going to work backwards because technically we're setting 8 equal to x root 2. By doing that, we're dividing by root 2. Okay? When we take 8 and that's equal to x root 2, what we're doing is we're dividing by root 2 on both sides. We're getting x is equal to 8 divided by root 2. Now, we wouldn't leave that root on the denominator, okay? We wouldn't leave that there. Let me move this over. Oh, okay, that's not going to work. Let me move this over to the right. And so what would happen here is by dividing by root 2, we would be multiplying by root 2 over root 2 to get rid of this denominator. And so we end up getting 8 root 2 over 2, which is what I was saying, which was our little trick. Divide by 2, multiply by root 2. You end up getting 8 divided by 2, which is 4 root 2. So each of my sides would be 4 root 2. Now, keep in mind, with the 45, 45, 90, you kind of have a fail-safe, meaning you can always set these equal to x for a 45, 45, 90. That is not the case for a 30, 60, 90 special right triangle, where across from the 30 degrees, I'm going to call this A. Across from the 90 is 2A, and across from the 60 is A root 3. So basically, if I said across from the 30 was the number 5, then across from the 90 would be 2 times 5, which is 10. And across from the 60 would be 5 root 3. If this number instead was 7 root 3, then 7 would be my A, okay? And across from the 30 would be 7, and across from the 90 would be 2 times 7, which is 14. Now, the problem again with this type of problem is that you're going to end up getting this number here being not a root 3. So if that was not a root 3, okay, let's just say that this number was 15, all right? You would have 15 equal to a root 3. And again, you're going to divide by root 3. So I'm going to take 15 equals a root 3, and I'm going to divide both sides by root 3. Well, in doing that, what's going to happen is these cancel and make 1. I get a equals. And 15 divided by root 3, you're not going to leave a root on the denominator. You're going to multiply by 1 in the form of root 3 over root 3. So you're ending up getting 15 root 3 divided by 3. So this actually should give you a clue to what you did in the other 45, 45, 90, where we were dividing by 2 and multiplying by root 2 at the same time, in this 30, 60, 90, I'm dividing by 3 and multiplying by root 3 at the same time. So therefore, A is going to equal 5 root 3. So across from my 30, I get 5 root 3. So there's my 5 root 3 is A. So then across from my 90 is going to be 2 times that. And so 2 times 5 root 3 is going to be 10 root 3. Okay, and so that's going to be this number right here. So that's 10 root 3. Okay, so if this is a little bit tricky for you, then I would suggest you watch the previous video on special right triangles, and we go a little bit more into depth on that. A couple more warm-up problems are, and these are just simplifying some roots. We have 3 root 60. Reducing this would be 3 times, let's say, what perfect square actually goes into 60. And if you don't know, we can start off with 6 times 10, because I think a lot of people will actually go into and start this way. Well, this is we're going to keep breaking this up. 6 becomes root 2 times root 3. Root 10 becomes root 2 times root 5. Now, the two that are the same are root 2 and root 2. Well, square root of 2 times the square root of 2 is the square root of 4, which is 2. So far we have this 3 times the 2 from the root 2's, and then we have root 3 times root 5, which is root 15. So my final answer here would be 6 root 15. That would be my value. For this problem right here, remember this root does fall over the entire fraction. So this would actually be root 3 divided by root 10. Now, we are not going to leave this root on the denominator again, and we are going to multiply by 1 in the form of root 10 over root 10. And so that's going to be the square root of 30 over root 10 times root 10 is the square root of 100. The square root of 100 is just 10. Now, just keep in mind that you are not going to break into a root. You can divide roots with roots. So for example, if I had, let's say, root 10 divided by root 5, I would get the square root of 2, okay? But you can't divide 10 into the square root of 30 because they're not both roots. So this right here is actually my answer that I'm done simplifying. This question says, find the geometric mean between 4 and 18. So you would say 4 is to x as x is to 18. You would cross multiply, you're going to get x squared equals 4 times 18. And you're going to square root both sides, which means you're going to get x equals the square root of 4 times the square root of 18. Square root of 4 is 2. So far I have 2 times. Now, square root of 18, I'm going to break that up into root 2 times root 9. And what that's going to do for me is that's going to say, well, root 9 is 3. So there's 3. That's going to be multiplied out front. So I've got 2 times 3, which is 6, times root 2. So my final answer for this problem here is going to be 6 root 2. Okay. Now this one on the right, it's 1/2 and 2/5, and I'm still trying to find the geometric mean. So for this one, what I'm doing is I'm going to go 1/2 is to x as x is to 2/5. Now I don't have a lot of room here. So I'm going to try to write small, but this is going to be x squared because I'm going to multiply across x times x squared. And that's going to equal these two numbers here, which is 1/2 times 2/5. Now, 1/2 times 2/5, the 2's are going to cancel and make 1. So I actually have the x squared equals 1/5. So x squared equals 1 over 5. And again, what I need to do for this problem, and try to get this, is not, need some more room. So I'm going to bring that down. Let's see what happens with, oops. Okay, so what that does for me here is, all right, that's going to give me a little bit more room. Okay, so I'm going to take the square root of both sides. Okay, so I'm going to have the square root of x squared and a square root of 1/5. So that's x equals, this right here is going to be the square root of 1 over the square root of 5, which is 1 over root 5. I'm going to multiply by root 5 over root 5. And so what that's going to give me is 1 times root 5. So x is equal to root 5 over root 5 on the bottom times root 5 is root 25. And the square root of 25 is 5. And so this is my answer, root 5 over 5. This one says a diagonal of a square has length 8. So I'm going to draw in a square. It says it has length 8. So here's my diagonal right here. So there's 8. It's a square, so I know the sides are congruent, which means it's actually a isosceles right triangle. And remember the little trick here we did on the previous slide, x root 2. So really what I could do is I could set this equal to x root 2. Or I could do the trick with this, which is take the number 8, divide by 2, multiply by root 2, and then my sides are going to be for root 2, both sides. For this one right here, this one is an equilateral triangle, which means that all of my sides are congruent. And if they're all 5, that's 5, 5, that's 5. If it's equilateral, all my angles are congruent, which means they're 60 degrees. And then when I bring down my altitude, like this right here, okay, what that's going to do is that's going to give me, this side is going to be 2.5 or 5 halves. And that's across from the 30 because this 60 up top, remember it's an equilateral triangle, so all the angles are 60. So that makes that 30. So across from the 30 is A. Across from the 90 is 2A, which is 5. So across from the 60 is A root 3. So this altitude would be 5 over 2 root 3. Okay, so find the length of T such that the triangle ABC is an obtuse triangle. So an obtuse triangle, if this is an obtuse triangle, then you would know that C squared has to be greater than the sum of the squares of the two other sides. So A squared plus B squared. Well, if A squared C squared's got to be the highest number, that's 8. So that's going to be 8 squared has to be greater than. So 64 has to be greater than some number squared plus B squared. Well, and we'll say that that's 4 squared. So we'll say 4 squared plus some other number squared. So 64 minus 16, so you would subtract that. So 64 minus 16 is what? 548. So 48. So B squared is less than, or 48 is greater than B squared. So that's a value that you could square root both sides. And keep in mind that when you square root a number that's not a perfect square, you would get an approximate value. Okay. Next, we have this value where we're trying to find x. So we have x squared plus 2 squared is equal to the square root of 5 squared. So we have x squared plus 4 is equal to 5. We have x squared equals 1. We're going to square root both sides, and we've got x is equal to 1. And on the denominator, or on the bottom here, we are going to try to find x, y, and z. We don't know the angles, but we are going to use a ratio. So the first one I'm going to find is x. So I'm going to go 5. Base is to height. So 5 is to x as x is to 10. And across multiply, I get x squared equals 50. X is equal to the square root of 50, which becomes root 25 times root 2. So that'll be 5 root 2. So x is equal to 5 root 2, or the square root of 50. And the reason why I might leave it as the square root of 50 instead of 5 root 2, even though I know that that's my reduced answer, is because when I might use the Pythagorean Theorem for this. And if I do that, I would go a squared plus b squared is equal to c squared. And I would go the square root of 50 squared plus 10 squared is equal to z squared. So I would say 50 plus 100, which is 150, is equal to z squared. I'm going to square root both sides. I'm going to get z is equal to what goes into 150? Well, 25 does. So we could say 25 times 6. So that's 6 right there. And so that would be 5 root 6. Okay, is equal to z. So that would be that value. And then for y, I could do the exact same thing and use Pythagorean theorem, or I could do a hypotenuse leg. I could say hypotenuse, which is 15, is to the hypotenuse is to the leg y, as the hypotenuse y is to the leg, which is 5. So that's another option I could do. Either way, I would get the same answer. That would give me y squared equals 15 times 5. And that would give me y equals the square root of 5 times 3 times 5. So that's my answer is going to be y equals 5 root 3. And so that would be my final answer for this value on the side left. For this problem, this says find the length of the diagonal of a square. So here's my square. The diagonal is what I'm looking for. I know that this value is x, and I have sides of 3 and 3. So x root 3. So x would be 3, x, okay. That would be 3 root 2. So that would be 3 root 2. Okay. So we're going to get started with trigonometric ratios. And so you will need a calculator at some point working these out. But for right now, we're going to just get started with what a trigonometric ratio is. And those are using sine, cosine, and tangent. And their inverses, which are arc sine, arc cosine, and arc tangent. And it's some people say inverse sine, inverse cosine. I don't ever say that. We know that they are inverses, but we say right here, when I see this, I'm going to say arc sine. So I'm saying arc sine out loud. I'm saying arc sine, arc cosine, arc tangent. That's what I'm actually saying out loud. But what I'm writing is this. That's arc sine, this is arc cosine, and this is arc tangent. So I'm going to get to that in a minute, but today, right now, we're going to look at the trig ratios, okay? Now, if you notice that sine, this is what you see, that's what you write, this is what you say. This is what I say, cosine, but this is what I write, cosine. As I write the word TAN, I'm saying tangent out loud. I say the whole word, even though I'm just abbreviating it. I'm saying this, but I'm writing this. So if I were to say something like sine of 30 degrees, I'm actually saying the whole word. If I were to say tangent of 30 degrees, this is what I'm writing. This is what I'm saying, tangent, okay? Now, these ratios, your job is to find trig ratios for sine, cosine, and tangent for the acute angles of a right triangle. This is our objective, okay? And of course, you're going to need to know what sine, cosine, and tangent mean, but these are our objectives. So today we're going to look at special trig ratios for these three values, sine, cosine, and tangent. And you're only going to use these trig ratios when you have a right triangle. So the first one we're going to start with is sine. So sine of angle A. So this is actually, you should say sine of angle A. So we're going to put a little angle in there. So sine of angle A, here you are. It's sort of like you put yourself at the angle. There you are. Or if you have shorter hair, there you are. You put yourself at the angle. Okay, and so if you're going to say sine of angle A, what you're actually saying is the opposite angle, the opposite side of that. So this is the opposite side here over the hypotenuse here. Remember, your hypotenuse is always going to be opposite your right triangle. Okay, so what we have is sine is opposite over hypotenuse. So you do need to make sure that you know which side is opposite. So for example, here's a right triangle. If you're standing right here, okay, then the side opposite you, which is where you're at with this angle, the side opposite that is here. Okay, however, if you were standing here, the side opposite you from here would be down here. So it depends where you're at. If you're going to be at this corner, or if you're going to be at this corner. Those are vertices. Which one are you going to be at? Regardless, you're going to be using, in order to find the sine, which is a trig ratio, a ratio meaning you're comparing two sides, is going to be opposite over hypotenuse. Now remember, the hypotenuse, right, is always the side opposite the right angle, okay? So let's look at cosine of an angle. Now cosine of an angle is going to be what we call the adjacent side. So like if you're standing here, again, here you are, and there you are at this angle, which side is adjacent? So we know if you're at A, this side is the opposite, okay? But you would use that with a sine ratio. With cosine ratio, you would say the adjacent side. So this side is actually adjacent, okay? That's your adjacent side. This still my hypotenuse because it's opposite my right angle. So you would say the adjacent side over the adjacent side over the hypotenuse. Now, depending on if you moved yourself and now you're here, okay, you would say the adjacent side now became this side over the hypotenuse. So depends on where you're at, okay? So if I'm talking about cosine of angle A, this is the only angle I'm talking about. So the adjacent side, okay, so if I'd say cosine of angle A, all right, that's going to equal the adjacent side, which is B, over the hypotenuse, which is C, okay? So in the previous problem, I said, what sine of angle A? So if I were saying, well, sine of angle A, notice I don't put an angle there for this. I just put it there because it's sine. I wrote it out. So sine of angle A is equal to, for this one, remember it's opposite little a over the hypotenuse, which we are calling C, right? So that would be the ratio. So again, for cosine of angle A, here we are, that would be the adjacent side over the hypotenuse. Now for tangent of angle A, so we'd say tangent of angle A, there, you're here again, all right? So there you are. Tangent is what we say opposite over adjacent. So that's the opposite side over the adjacent side. So you would say A over little b. Now keep that in mind. What if I moved myself up here? And if I had said instead, here I am, all right, and I want to find tangent of angle B, it's still going to be opposite over adjacent, but that's now my opposite side. So if I said tangent of angle B, my new side that I'm opposite of is little b. My adjacent side is A. So B over A, opposite over adjacent. So what we're going to do with this is a little bit of practice, okay? Keep in mind that, the little sides, the sides are usually the smaller letters. So this is capital E, this is little e. We want to find little e, let's say. We could use Pythagorean Theorem, or we could just remember that this is a triplet. And so therefore, this is a 3 what? This would be a 3, 4, 5, right triangle. That's a 5, 12, 13. Anyway, sine of angle F. Okay, sine, you put yourself at the angle that you're looking for, okay? So here you are at F. So sine, again, sine is opposite over hypotenuse. So sine is going to be opposite, the opposite side, which is 3, over my hypotenuse, which is 5. So 3 over 5. So that would be the ratio for that. For this one, we have sine of x. So now I have to put myself at x. So x is here. So I'm going to, some people draw themselves there. Some people like circle the x, whatever you have to do to make yourself understand that you're at that angle. Now, remember, you're never going to be at the right angle. Don't ever put yourself at that angle, okay? So here we are, sine of x, opposite over hypotenuse. So that's going to be opposite over hypotenuse is going to be 12 over the hypotenuse, which is 13. So that's the ratio. For this next one, I need to find sine of y, which means that now I have to move myself over here. sine is still opposite over hypotenuse. So you put yourself at y and you say, okay, the opposite is going to be 5. So the opposite side is 5, and my hypotenuse is 13. So that's 5 over 13. Okay. So practicing with cosine, now remember, cosine is adjacent over hypotenuse. Every one of these is cosine, so they're all going to be adjacent over hypotenuse. So for this one, this says cosine of f. So I'm going to put myself here at f, and which side's my adjacent side? Now it's not 5, that's my hypotenuse. So my adjacent side is right here, but I don't have a value for that, so I might have to use the Pythagorean theorem. We do know actually that that's a 3, 4, 5 triangle because it is a triplet. So we're just going to say that it is 4. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse is going to give me 4 over 5. Now, to find cosine of x, again, adjacent over hypotenuse. So here you put yourself at x. The adjacent side is 5 because the other side that's connected to my vertex is 13, but that value can't be an adjacent side because it's already a hypotenuse. So the adjacent side is going to be 5 over my hypotenuse, which is 13. Now this problem says cosine of y. So now I'm going to put myself at y. Cosine again is adjacent over hypotenuse. If I know that this is my hypotenuse, it can't be the adjacent side. So the adjacent side is 12, so it's going to be 12 over 13. That's the adjacent over hypotenuse. So practicing with tangent, so here we are at f, tangent. Tangent is opposite over adjacent, and you don't use the hypotenuse at all. I'm just going to cross that out, not so that you don't get confused, knowing opposite over adjacent doesn't offer the hypotenuse. So F, tangent, opposite over adjacent. The opposite side is never connected to the vertex, so know that. It's other than with the arm, it's connected out here. So opposite is going to be 3 over the adjacent side, which is 4. Tangent of x, so tangent, okay, tangent, you're here at x, opposite over adjacent. So that's going to be 12 over 5. Please keep in mind that this is a ratio where you're comparing two sides. You are not going to reduce that into a mixed fraction, okay? Don't make that 2 2/5. Do not do that, okay? So tangent of y, now we're going to put ourselves here, tangent, opposite over adjacent. Again, tangent is always, that's always going to be opposite over adjacent. So that's going to be 5 over 12. And you always try to reduce these if you can. None of these are reducing. Okay, so there are some ways to remember sine, cosine, and tangent. And we actually have these mnemonic. A mnemonic is something that helps you remember something else, like homes. Like you learned this in geography, right? Homes, Huron, Ontario, Michigan, Erie, Superior. Homes are Great Lakes, right? And so, that's a mnemonic. That's what that is. It's something that helps you remember something else, like PEMDAS. Parentheses are first, exponents are next, like that kind of thing. So we call this SOHCAHTOA. So try to practice that a little bit, saying that. You say SOHCAHTOA, 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 SOHCAHTOA. Okay. And what the little mnemonic says is, see the sign? S stands for sine. So that sine of an angle is equal to the opposite side over the hypotenuse. CAH, cosine of an angle, and this is theta, by the way. Cosine of an angle is the adjacent side over the hypotenuse, and tangent of an angle is equal to the opposite side over the adjacent side. Now, remember what I said, that even though I write TAN or COS, I'm actually saying the entire word. I'm saying tangent of an angle. I'm saying cosine of an angle, sine of an angle. I'm saying the entire word. A couple of other things. This right here, we discussed this earlier in another video, but that's theta. Theta is an angle. It represents an angle. There's lots of different angles that are all Greek letters that we use to represent angles, like theta, We've got beta, we have alpha, we have omega, we have phi. There's a lot of different things that you can use. Most common probably is theta or alpha. We use either one of those. So if you were here at theta, the opposite side over the hypotenuse, again, that's sine. So it's just a mnemonic. It's something that we use to help you remember. So sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent is the opposite over adjacent. So that's your SOHCAHTOA, okay? So let's just practice here. Let's say you're standing here at x, okay? I want to find the sine of x. Sine is going to be opposite over hypotenuse, so that's going to be A over my hypotenuse, which is C. And if it makes you feel better to put hypotenuse here, go ahead. So that's opposite over hypotenuse, so that's going to be A over C. Cosine of x, so cosine is adjacent over hypotenuse, so that's B over C. And tangent is opposite over adjacent, which is A over B. Sine of z, now this is telling me that I'm moving. So now I'm here. So sine is going to be opposite over hypotenuse, so that's B over C. Cosine is going to be adjacent over hypotenuse, so that's going to be A over C. And tangent is going to be opposite over adjacent, which is B over A. And again, it just matters where you're standing at will depend on which vertex are you at, and you're not ever going to be at that right angle, ever. So this is another example, but of the same slide that was in the previous page, but this is a 3, 4, 5 triangle, but now we're going to actually use numbers instead. So if I wanted to find the ratio for sine of x, I'd put myself at x, sine is opposite over hypotenuse. So this is where I would actually advise you to halt the video or pause the video for a second, fill these in yourself, and then come back to the video. So let's say you did that. Sine of x is going to be opposite over hypotenuse, so that's going to be 3 over 5. Cosine of x is the adjacent side over the hypotenuse, so that's going to be 4 over 5. And tangent of x is opposite over adjacent, which is 3 over 4. Now, for sine of y, here's y. Sine is going to be opposite over hypotenuse, so that's going to be 4 over 5. Cosine of y is adjacent over my hypotenuse, so that's going to be 3 over 5. And tangent is going to be opposite over adjacent, so that's going to be 4 over 3. And again, I want to just advise you, just because it's top heavy, just because you're thinking, oh, I need to make that into a mixed fraction, you don't. It's a ratio. It's comparing two sides. Leave it alone. So a couple of other things. Let's say, what is sine of 30? Well, let's say we put ourselves here at 30 degrees. Okay, there you are, or there I am. And you're here at 30 degrees. Sine, remember what sine? Opposite over hypotenuse. So this is 2 over 4, which does reduce to 1/2. Okay, and this is what we got when we found sine of 30 degrees. Now, well, let's say I was over here at this angle, that triangle. So put yourself here. All right, there you are, sine of 30. So let's do that again. Sine of 30 degrees is equal to opposite over hypotenuse. So that's going to be 5 over 10. And sine of 30 ends up being equal to 1/2 again. Okay, so do you think this is a coincidence, or is sine always going to be a half? And if you said it's always going to be a half, then you'd actually be right. Okay, we'll get into that soon. An extension for this one right here is I want to know tangent of 45 degrees. Well, again, put yourself here. There you are, 45 degrees. Tangent is going to be opposite over adjacent. So tangent of 45 degrees is equal to 2 over 2. So that equals 1. Tangent of 45. So here we are on this triangle here. Okay, tangent of 45, opposite over adjacent. So tangent of 45 is equal to 6 over 6, which again, is 1. So what do you think? Coincidence? No. It's always going to be 1. These are always the right triangle. And you know that if it's a 45, 45, 90, that the sides are going to be congruent. So you know then that the two sides, if you're at one angle or the other, you're going to get the same value. So it's always going to be opposite over adjacent, or if you're here, it'll be opposite over adjacent. It's still going to be 6 over 6, which is 1. So what we're going to do now is we're going to incorporate an angle. Now, I do want to stress this, that when you're finding sine, cosine, and tangent, so I'm going to use the SOHCAHTOA. SOHCAHTOA. Sine, cosine, tangent. Sine is opposite over hypotenuse. So if I were to write this out, sine of an angle is equal to opposite over hypotenuse. Cosine of an angle is equal to AH, which is adjacent over hypotenuse. And tangent of an angle is equal to the opposite side over the adjacent side. I do want you to understand that right here, and right here, I'm putting the angle right after the actual word. So I'm finding sine of an angle. What has to happen here is that has to be an angle. So you need to always have an angle after that word, whether it's the trig function of sine, cosine, or tangent, you always have to have an angle here. So we're going to assume that we're here at 67 degrees, okay? And so there you are. So we're going to say, well, I need to find x and I need to find y. So we're going to find one thing at a time. Let's just say we're trying to find x. If I want to find x and I'm standing here, what is that? Is that my hypotenuse? No, that's my hypotenuse. This is the side opposite from what my angle is. This side that I have is the adjacent side. This side is the opposite side. Which one of my trig functions uses the opposite side and the adjacent side? And if you said tangent, opposite, and adjacent, then you'd be right. So let's write our trig function. So everybody should write this down. This is going to say tangent of 67 degrees is equal to the opposite side over the adjacent, which is 35. Now, this is where I ask you to get a calculator. Okay, so now what I'm going to do here is I'm going to split my screen. And by doing that, okay, let's see here. Let's see if I can do that. I'm going to split my screen because what I need to do is I need to have a screen for my calculator. Let's see how, I think I can fix it like that. I need to have a screen for my calculator and I need to have a screen for my, there we go. And I need to have a screen for my examples. So the first thing you're going to need to do, all right, is you're going to need to get a calculator. Now, these are the TI Inspires. This is similar to the one that we use in our classroom. So any any scientific calculator is going to be fine. It's going to work. But there's a couple of things that you need to understand. And the first thing is we're in degrees. See the little degree sign? Your calculator needs to be in degrees. So what I need you to do is see here where it says calculate. You need to go to you need to go over to the right to where it says new document, okay? And then, oops, before we do that, I have to escape because I guess I clicked it twice. I need to scroll down to settings, okay? So move this part right here on your pad, the little track pad. You're going to move it over to the right and down to settings. And then you're going to click on document settings. You need to be in degrees. And in this calculator right here is in radians. And radians is something that we're going to discuss later on. Make sure your calculator is in degrees, okay? And you would say, okay, I'm going to make that my default because if I make it my default, then every time I start a new screen, I'm always going to be in degrees. And you'll notice that in the top right-hand corner of your calculator, see, which is right up here in the corner, that's going to say degrees. Okay, so what I need to know is what's tangent of 67 degrees. So on this calculator here, I'm going to click in the left-hand corner and it's going to say trig functions. I'm going to go over to where it says tangent. So you'll see, you can't see, it's not big enough. I need tangent, there we go, of 67 degrees. So I'm going to say 67 and I'm going to press enter, but you actually need to be careful because if I just press enter, I get that. And that's not what I want. I want an approximation to what tangent of 67 degrees is. So see this part right here where it says control? You're going to press that, control and enter, because what that does is that gives you an approximation. If you notice on your screen, down below, down here, okay, it looks like this, all right? That sign, that's above the enter. So you're going to go control enter because anytime you push the word control, that's going to give you all these lighter functions, okay? So anyway, so tangent of 67 is approximately, we're going to go with 2.36. So tangent of 67 is 2.36 is equal to x over 35. And so now all I have to do is cross multiply. So x is approximately 35 times 2.36. So I'm going back to my calculator and I'm going to take that answer and I'm just push times and it'll automatically save my answer down here. 35, and then I'm going to press enter and that's going to give me approximately 82.45 or because this is a length of a side, I'm going to round to the nearest tenth. So that's going to be 82, what was that? 82.5. And that's going to be the value of x. So 82.5. Okay. Now, I also have to solve for y. Okay. So going back to y, in order to find y, I'm still here at this angle, and therefore, still here at 67 degrees, I need to find y. So a couple of things. Number one, I can say one option is cosine of 67 degrees is equal to the adjacent side, which is 35, over y. I could say that's one option. Another option is to say sine of 67 is equal to the opposite side, 82.5 over y. Either one of those is going to give me a correct answer. The difference is that one is sine and one's cosine, and that's it. So I'm just going to use, let's just use the original cosine one up here. Okay, so cross multiplying, I'm going to come down here to the bottom. Cosine of 67, so cosine of 67 degrees equals 35 divided by y. I need to know what cosine of 67 is. So I'm going to go over to my calculator and I'm going to type in cosine, and I find cosine by the trig function here, and I'm going to press cosine, and I'm going to press cosine, there it is, and that value is going to be of 67 degrees. So again, remember, you're going to hit control and then enter, and it's going to give me an approximate value, 0.3907. So generally, when you're taking approximations, 3907, 0.3907. Generally, you go tens, hundreds, thousands, 10,000s. You go 4 decimal places, and that's going to give you more of an accurate. The more values you go, the more accurate your answer will be. Now we have to cross multiply. So we're going to get 0.3907 times y equals 1 times 35. I'm going to divide both sides by 0.3907. So that and that are going to divide by 0.3907. 0.3907. And so these are going to cancel and make 1 times y, which is just y. And now I have to use my calculator again and go and type in what's 35 divided by 0.3907. So now I'm going to say 35 divided by point, and I can actually type in 0.3907 Or I can use the value that says answer. And if you notice above the minus sign, it says answer. So anyway, so that's going to be 0.3907. And I'm going to type in equals, and I get 89.58. So y is approximately 89.58. So we'll go 89.6. Because I am talking about a length of a side, I'm going to use 89.6. I'm going to round that off to the nearest tenth. So a couple of things that I wanted to talk to you about. We have x, we have y, we use our trig function. Great. What I want to talk to you about is that your right angle, which is this angle right here, the side opposite the right angle does need to be the biggest side because the right angle is the biggest side in the triangle. So a couple of things. So I'm just going to redraw this triangle because it has a lot of stuff on it. This is 67 degrees. All right. You should know that this angle plus this angle are both add up to be 90 degrees. And if this angle right here is 67, this angle here has to be 23, right? Because 23 and 67, 23 plus 67, 0, 1, 6, 7, 8, 9, add up to be 90 degrees. So my smallest angle is 23. My opposite side is 35. So that should be my smallest side if it's opposite my smallest angle. In addition, the 67, this is 82.5. This side here is 89.6. If this is my right angle, which is my biggest angle, the side opposite that has to be the largest side. So just keep that in the back of your head so that you do know that. We need to find the value of each variable for this. I see that both x's are exactly the same. So for this problem, it looks like just looking at this triangle here on the left, all right, that's x, this is y, and this is 40 degrees. This is 9, because if this looks like an isosceles triangle, this altitude does cut that base in half, leaving this 9 and that 9, okay? Now, you can't just use our little tricks where we said like x root 2, or, a, 2a, a root 3, or anything, because those were special right triangles. Those are 30, 60, 90s and 45, 45, 90s. This is a 40, not a 45, 45, 90. This is a 40, which basically means this angle, remember, is 50 because they have to add up to be 90. There's 90 and 90 is 180. Okay. Your options are, you can put yourself at this angle or that angle. Pick an angle that you like and put yourself there. So now in order to find y, I'm going to use opposite over adjacent. So I'm going to say tangent of 40 degrees is equal to the opposite side over the adjacent. So now I have to go back to my calculator and figure out what tangent of 40 degrees is. So I'm going to go to trig functions, going to hit tangent, and then I'm going to type in 40. And remember, I need to go control equals to get an approximation. And that value is, I just lost it, 0.8391. And that equals y over 9. So to find y, I need to cross multiply. Okay, so I'm going to go 1 times y, which is y. And then I've got to go 9 times 0.8391. So now I'm going to go back to my calculator, and all I have to do is actually push x, or times, because what that does is it automatically takes my answer right there and it'll times. Now I want to times that by 9, press return, and so now I have 7.56. So 7.5, sorry, I'm going to go with 7.6. Sorry about that. So 7.6. So this is x, or excuse me, this is y. Now y is 7.6. So this value here 7.6. Like the other on the other problem, I forgot to mention this to you, but I could also use Pythagorean Theorem to find the third side. Once I have two sides, see if you notice I have two sides where before I only had one side, so there's no way I could use Pythagorean Theorem. But I could, let's just use that for practice, 9 squared plus 7.6 squared is equal to x squared. Now, I need to add these up. I'm going to use my calculator. I'm going to go 9. Oops, I'm down here. Let's put myself down here. I'm going to go 9 squared. There's squared. Plus, so there's plus 7.6, and that's also squared. See, I'm pushing this button over on the left-hand side that has the x to the squared on it. Okay, and that's equal to, so let's see, equals that. And so x squared, so on this page I have, let me move this over, 138.76. So 138.76 is equal to x squared. So now I have to square root both sides, and I'm going to get x is equal to about, because I am approximating, because I did round, the square root of that. So for now what I have to do is find the square root sign. So I'm going to go square root. Okay, I don't know where I'm at here, down here. Okay, I'm going to go control this, because you'll notice that on your calculator, in order to get the square root sign, you need to go second, which is control. So what goes in here, I'm going to type in 138. Oops, okay, I just lost my root. Let me put that back in there. Control square root of 138.76. And I'm going to enter, and I get 11.78. So x is about 11.78, so we'll go 11.8. And look at your answer and ask yourself, does this make sense? Because is that the biggest side? Because remember, the biggest side has to be opposite the biggest angle. And this is the biggest angle is my right angle. So therefore, this has to be the largest side. And then my next largest side is 40 degrees, or excuse me, my smallest side, my smallest angle is 40 degrees, which means 7.6 is my smallest side, because my smallest side is opposite the smallest angle. Okay, so practicing with sine, cosine, and tangent, this is just asking you to find two different equations to find x. So in order to find x, let's see, I don't have this side. So I could be here at tangent, or excuse me, I could be, let me just say here. If I put myself at this angle here, okay, there I am, okay. If I put myself here at this angle, this side is the adjacent side. So I'm trying to find the hypotenuse. I have the adjacent side. Which one out of the SOHCAHTOA, which one of those uses adjacent and hypotenuse? Well, that would be cosine, right? So you would say cosine of 35 degrees is equal to the adjacent side over the hypotenuse. Okay, so that's one way of solving that, okay? And you would have to solve for x, and we're going to do that. But another way of doing that is to put yourself at the other angle. So let's say now I'm going to be here, okay? And so there I am, and from here, I'm at 55 degrees here, and I have the side opposite, and I'm trying to find the hypotenuse. So the side opposite is sine. So I'm going to say sine of 55 degrees is equal to the opposite side, which is 5, over the hypotenuse. So notice that these two angles are not the same, because I'm at two different corners. I'm at two different vertices, okay? So you got to just pick one. I'm just going to use cosine. I need to find cosine of 35 degrees. So in doing that, I'm going to use my calculator. So I'm going to come over here and I'm going to go trig function. I have to be down here. I'm going to go trig function, and I decided to use cosine, and that's going to be cosine of 35 degrees. And I need to know what that is. Remember, you're going to go control equals, okay? And keep in mind, you guys, that different calculators are different. And so you don't always have to go control enter. You just have to do that on this calculator because it's testy. Anyway, so cosine of 35 degrees is going to be 0.8192. So this here is going to be 0.8192 equals 5 over x. We're going to cross multiply, solve for x. We get 0.8192x equals 5. I want x by itself, so I have to divide both sides. So I'm going to divide both sides by 0.8192. And I'm going to get x is equal to that, 5 divided by 0.8192. I don't know what that is. Let's use our calculator. And so we're going to go 5 divided by the answer. Let's see if I can do that. I think that's what that says. Control answer. There it is. Okay. So I don't want to, let's say I don't want to retype that. I just want to write answer. Okay. That's what I would do. And so, 5 divided by that is 6.1. So, x is about 6.1. All right. So there's 6.1. There you go. And just kind of give it a test because it has to be the biggest side. So if across from the 55 degrees is 5, then across from the 90 better be bigger than across from the 55 because that has to be the biggest side. Okay? All right. So state 2 different ways we can find x. All right. So one way to find x is I'm going to put myself at this angle up here. Okay, there I am. And I'm not going to use, if I'm here, this is my opposite side. I don't have that. I'm not going to use any of the problems that say opposite. So if I'm thinking of so, ka, toa, because I don't have this value here, I'm not going to use tangent and I'm not going to use sine because I don't have the opposite side. So I have to use cosine, okay, for this problem here. So here we go. For here, we're going to go cosine of 47 degrees is equal to the adjacent side, x, over the hypotenuse. So x over the hypotenuse, which is 13. This is adjacent side over hypotenuse, a over h. Okay, so we need to find out what cosine of 47 is first. Okay, so we're going to find cosine of 47. So I go trig function, cosine of 47, and that is approximately, so I'm going to go control, enter, and that's going to give me 0.682. So we're going to say that's going to be 0.682 equals x over 13. I'm going to cross multiply, and I'm going to get x is equal to whatever 13 times 0.682 is. Okay, so let's figure out what that is. So I'm going to go answer times 13 equals. And I get 8. Let's say 9. So x is about 8.9. And this is 8.9 because it's an approximate. We round it off. And so therefore it's an approximate value. Now, remember it asked me originally 2 separate equations. So I'm going to come up with another equation. All right. And I'm going to try to use, let's see, what are we going to use? Let's use this angle. What's this angle here? Okay. I want that angle. So to find that angle, that's going to be what? 43? And is that right? How do I know what that angle is? Well, you would take 90 and subtract 47 degrees. Okay, so 9, borrow 8, that's going to be 43 degrees. Okay, so there you are. So put yourself at that angle. So now you're here at 43. Okay, let me erase this other stuff. Okay, so we're not up here anymore. We are down here. And so in doing that, all right, putting ourselves down here, what we're doing now is we're saying, okay, where do I know? Well, I don't have the adjacent side, so I'm not going to use anything with the adjacent side, and I don't want to find it, so I'm not going to look for that. I'm trying to find the opposite side. I have the hypotenuse. You can only have one unknown. Our unknown is what we're trying to find, which is the opposite side. So which one of these is going to use the opposite side? Is it going to be sine, cosine, or tangent? So again, I'm going to rewrite this. We've got sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So because I'm not trying to find the adjacent side, nor do I have it, I'm not going to use tangent because that uses the adjacent side. And I'm not going to use cosine because that also uses the adjacent side. So I have to use sine. So I'm going to go sine of 43 is equal to the opposite side, x, over 13. And I'm going to cross multiply. X is equal to 13 times whatever sine of 43 is. And I want to find out what that is. So on my calculator, I'm going to come over here and I'm going to say sine. So I'm going to click on sine. So I'm going to click on sine and I get sine of 43. Okay. And I can actually just type this all in one time and I can say that times 13. Okay. But because I'm not using a decimal here, I need to approximate my answer. Let me show you what I would get if I didn't approximate. If I just hit enter, I get the same thing. Okay, it's just like, well, there you are. But if I want an approximate answer, I'm going to hit Control Enter, and that's going to give me my approximate answer, which is 8.86, which again is going to be 8. If I round up, right? If I round that up, it's going to be 8.9. So X is about 8.9 again. And of course, you should get the same answer. This is just giving you two different ways of finding the same answer. So the flip side to doing this is not just finding sides, using to find their trig ratios, but also to find the missing angles. Okay, meaning what is X or W? So how would I find X? Now, let's do this example. Okay, so I'm going to rewrite this triangle on the left side. And in doing that, because these angles are the same, that tells me that my sides are the same. That tells me that it's an isosceles triangle, which means when my altitude pops down like that, it's going to split my base into two equal parts. So therefore, if this whole length is 16, then we have to divide this in half. This is going to be 8 here, and this will also be 8. So here's 8 here, all right? So I'm trying to find X, and in doing that, this is 10 here, okay? So of course I know if this is 10 and this is 8, this is a 6, 8, 10. But aside from that, I want to use sine, cosine, or tangent to solve this. So this is what's going to happen, okay? We have X is equal to, we have this angle is what I'm trying to find. Because I know all three sides, I can use sine, cosine, or tangent to solve. I can use any of those. So I'm going to say sine of X, because you remember, you always have to put the angle after the word. But if I don't have this angle, I have no idea what that is. If I don't have that angle, then that's unknown. So I'm going to use x. So I'm going to use sine is opposite over hypotenuse. So that's opposite over hypotenuse. So sine of angle x is equal to 6 over 10. I can reduce that if I want. It's not necessary right now because I need to isolate the x. And in isolating the x, by the fact of taking the sine and moving it over to the other side, the act of doing that is what we call the inverse or arc sine. I'm saying, this is what I'm saying out loud, arc sine. That's what I'm saying. I'm going to write arc sine like that, okay? 6 over 10. So what's going to happen is I need to know where that angle is. So by asking the inverse sine, that's saying at what angle or where are you? What angle? Where is the angle, okay, that is 6 over 10, that has a ratio of 6 over 10. So on your calculator, all right, you're going to go for where it says trig, and you're going to look for the arc sine. See that right there? Click on that. That's arc sine. And you're going to type in 6 divided by 10, and it will just reduce for you, so you don't have to worry about that. What you do have to worry about is that neither one of those are decimals. So again, you're going to have to do Control, Enter, and that's going to give me my approximation. And what I just figured out was that this is 36.9 degrees. So x degrees is about 36.9 degrees. And so that's the angle where I'm at. And so that's x. That's this angle here, 36.9 degrees. Now, so we know x is 36.9 degrees. Well, what if I want to find w? Well, that you don't have to do this whole thing again because remember, a triangle has a sum of 180 degrees. So, and these two angles here are complementary, meaning they both add up to be 90. So all I have to do is I now have to go, well, to find the other angle, so I'm going to just do it in my head. I just type in 90, subtract that answer, which is 36.9 degrees, and I go enter. And my other angle up top, okay, this angle right here is going to be, what did we say it was? 53.1 degrees. So 53.1 degrees. Okay. So what we're going to do now is we're just going to look at these application problems. It says the base angle of an isosceles triangle are 55 degrees. Now, we just talked about this. We just did this problem. So we have a base angle of an isosceles triangle are 55 degrees. So that's 55. That means that's 55 degrees. The base is 40 centimeters long. So that means that when my altitude, because I want to know the length of my altitude, the height of my altitude, okay, x, this value here is 20, all right? So now you have to ask yourself, okay, you don't know the hypotenuse. The hypotenuse is the side opposite the right angle. You don't know that. You don't want to find it. You don't care what that is right now anyways. And so you just want to find x. So you need to ask yourself, well, which one of my trig functions, is it sine opposite over hypotenuse, cosine, which is adjacent over hypotenuse, or tangent, which is opposite over adjacent? Which of these functions is going to give me what I need? I need to find the opposite side. I have the adjacent side. I don't have the hypotenuse. So the values that use the hypotenuse are not going to be used. So we're going to actually use tangent. So here we go. Tangent, remember the angle comes right after the word. Tangent of 55 degrees is equal to opposite over adjacent, which is 20. So I'm going to go x is equal to 20 times whatever tangent of 55 is. And so therefore, I'm going to use my calculator and I'm going to say, well, it's about, and remember, because I am going to approximate, I'm going to come over here and say tangent of 55. So trig tangent, tangent of 55 degrees. And you might have to use the arrow button, this on the trackpad to get out of the parentheses. You have to move out of those, okay? So tangent of 55 times 20, or maybe I should just say times here, 20. And again, none of my numbers have decimals in them, so I do need to go control equals, and that's 28.6 degrees. So this is going to be 28.6 degrees. So actually, that's not a degree. Hold on one second. 28.6, and that's the length of my altitude, which is about 28.6. I think we're in centimeters. Yeah, centimeters. Now, just keep in mind that I could find this length if they wanted me to. All I would have to do is use maybe Pythagorean Theorem, or I could use sine, cosine, or tangent to find that also, okay? But we don't need to. A tower casts a shadow 35 minutes. Now here, 35 meters long, when the angle of elevation of the sun is 32 degrees. Now, this is sort of our first problem that we've done with angles of elevation. So just keep in mind, angles of elevation are when you're looking up, okay? So you have a tower. So let's say here's my tower, all right? Super tall. It casts a shadow. So shadows, you need to know where a shadow is. A lot of people think this is a shadow. That's not a shadow. Shadows are always on the ground, right? Peter Pan, his shadows are like on the wall, but that he's special. Shadows are always on the ground, okay? The tower casts a shadow of 35 meters long, okay? The angle of elevation, that's the angle where you're looking up, that angle of elevation is 32 degrees. Your job is to find how high the tower is. So you have to find x, okay? You have to find x. You have this angle. You actually also have this angle too, right? Because you know that if that's 32, this angle here has to be 90 minus 32, right? Because this angle and this angle add up to be 90 degrees. So just subtract. I mean, I guess you could use your calculator or your brain. You've got 58 degrees there. So you completely have a choice here. You can either put yourself up here, okay, or you can take yourself and put you down here. You need to be at one corner. Remember, you're not ever going to be at the right angle. You're going to be at this end or at that end. I'm going to choose this end, and I'm going to show you why in just 1 second, okay? I'm going to write this down 2 different ways. If I was here, no, I don't have my hypotenuse. So if you remember your SOHCAHTOA, anything that uses the hypotenuse, and because they didn't ask me for, let's say, my line of sight, all right, I'm not going to look for the hypotenuse. I'm not using sine. I'm not using cosine because they both use the hypotenuse. I'm going to use tangent. So I'm going to go tangent of 32 degrees is equal to the opposite side over the adjacent, okay? That's from here, the opposite side over the adjacent, okay? I could put myself up here. If I did that, okay, I could say tangent of 58 is equal to the opposite side, 35, over the adjacent side, which is x. Now, the difference between these two is 1 step. I want you to see this. If I were to cross multiply, right, I'm going to get x is equal to 35 times tangent of 32. So all I have to do now is multiply tangent of 32 by 35. So let's do that, okay? X equals, let's see here, tangent, and here we are, down here, tangent, here's my trig functions. So tangent of 32, all right, times, where's times? Times 35 equals, oh, I forgot a decimal. Okay, control, enter. There we go. Is 21.9. So this is about 21.9. I think we're in meters. Okay, so that's what x is. Okay, that's the height. Now, had I used this form here, instead, I would be going x times tangent of 58 equals 35. And then I would have to divide x equals 35 divided by this quantity, which is tangent of 58. Okay, so you do have the option of doing both, but do you notice that this has one extra step? Okay, so let's just do this here. Oops, let's do this here. So we're going to go tangent. Where are we at? Tangent. And tangent, actually, I'm going to do tangent of 35. But before I do that, I'm going to come over to the other side and I'm going to say 35 divided by tangent of not 35, but 58. There we go. Now I have the right number. 35 divided by tangent of 58. I'm going to go control, approximate, and I get the same answer. Do you see that? 21.87. So that's about 21.9. Okay. So, and that's meters. So I get the same answer. Just a quick note. I want you to understand the difference between this problem and the previous problem from a couple of slides back. Remember when I was using arc sine or arc tangent? Remember when I was using the arc? You use that when you're trying to find an angle, okay? You only use the arc when you're trying to find an angle. So you notice that I'm not using arc tangent, arc sine, or arc cosine because I'm not trying to find the angles. I already have the angles. Whereas, not this one, but this one, see here, I didn't know what the angle was. So I used, in this case, arc sine to find the angle, right? So it's just a thought. When you're trying to find an angle, you have to use the arc sine, arc cosine, or arc tangent, okay? Use one or the other. Okay, so just a review. Let's do one more of these. Using inverse sine, cosine, or tangent. If you are here and you want to find that angle, okay, what do we have? You have to ask yourself, what do you have? You have this side, which is the opposite side. You have this side, which is the hypotenuse. So which one uses the hypotenuse in the opposite side? That's sine. So we're going to say sine of the angle is equal to the opposite side, which is 5 over 7.8. Okay, so we want to isolate the angle. So the act of moving sine, this value here, over to the other side is what we call arc sine. So now we have 5 divided by 7.8, and we get x is equal to, so you're saying, where is the angle that has a ratio of 5 over 7.8? So we're going to go back to our calculator, and we're going to use arc sine, trig functions, arc sine of parenthesis 5 divided by 7.8. And if any of my questions here have a decimal in it, all I have to do is press enter because it'll give me a decimal form. It's when I don't have a decimal in my answer or in my question, which will give me, the question where I have to go back. So because I am approximating, right, this is going to be about 39.9 degrees. Okay. So that's what x is about 39.9. And just so you know, had I wanted to find this angle also, I would just go 90 minus 39.9 degrees, right? Okay, so that's what x equals. 2 more problems to practice. I would try to find angle Y here, angle V here, and also side X, okay? So at this point, I would probably pause your video. I would try these problems on your own and then start it back up again. So I'm going to assume you did that. For this problem right here, I don't have the hypotenuse and I'm not trying to find the hypotenuse. So I'm going to use tangent because all I have, if I put myself here, okay, all I have is the opposite side. Here's the opposite side, and I've got the adjacent side. So tangent of the angle that I'm trying to find is going to give me the opposite side over the adjacent side. Okay, so all I have to do is I'm going to solve for y because I want to find the angle. So I'm going to say y is equal to arc tangent. So see this tangent? I'm going to move it to the other side. So that becomes arc tangent of 5.9 divided by 3.2. And so y is approximately, okay, so now I have to figure that out. Use your calculator. You're going to say, okay, I need to move this over a little bit. Arc tangent. So I'm going to go trig, arc tangent, here it is. Arc tangent of 5.9. So 5.9 divided by 3.2, enter. And so that's 61.5 degrees. So again, 61.5 degrees. And keep in mind, we're trying to find the angle. So if you're trying to find an angle, you have to use arc sine, arc tangent, or arc cosine. Okay? All right. So what I'm going to do here is the next thing we're going to do is we're going to try to find x. So I can use a couple of things. I can use Pythagorean Theorem. I can go 17 squared plus x squared is equal to 39 squared because I have all the sides, right? Or except for one. And so you could do that. That's option A. You also could, once I find an angle, I could also use sine, cosine, or tangent. So I just might do that too. What I think I'm just going to do for this problem to start is Pythagorean Theorem. So I'm going to go x squared is equal to 39 squared minus 17 squared. And then I'm going to square root what I get. Whatever that answer is, I'm going to square root that answer. Okay, so let's see what we get. So for this problem, the first part of the problem, I'm going to go 39 squared. So I'm going to hit the squared button minus 17 squared here. If I'm not using any decimals, remember, I need to go control approximate, and I get 1232. Now, that's not the answer because remember, it not only does it not sound reasonable, but I need to square root that. So we're going to go square root of that answer, and I'm going to enter. But I get 35.1. So that looks like x is about, oops, okay, wrong tool. So x is about, what was the answer? 35.1. So 35.1. So that's x. So x is 35.1, which, by the way, is reasonable because remember, the side opposite the right angle has to be my biggest side. And it is because this is less. Okay, so now let's find v. So you just have to decide what do you want to do. You put yourself at v. You don't have to. I could be at a different angle, but since I'm trying to find v, let's do it. Let's see, we're going to go, I like tangent, so we could go opposite over adjacent. I also like sine, where we could say, let's do sine. So sine of angle v is equal to the opposite side over the hypotenuse, which is 17 divided by 39. We're going to get v by itself, and so we're going to take sine and move it across the equal sign. And I know I keep moving this across. It's an inverse operation, people, meaning what you're seeing is this inverse operation such that if you had, let's say, x plus 2 equals 7, right? And you wanted to take this positive 2 and move it to the other side of the equal sign, right? To solve, you would subtract 2. Well, that's an inverse operation. See, plus 2, the inverse operation is minus 2. Likewise, if there was, let's say, a 3 in front of the x, and I wanted to solve for x, instead of see how it's 3 times x, I would divide by 3, which is an inverse operation. So technically, that's what I'm doing. I'm taking sine, I'm moving it across the equal sign, and I'm performing an inverse operation. Inverse sine, that's why they call it that. Some people call it inverse sine. I call it arc sine because that's the better way to say it. So we are now going to go arc sine of this value. So we're going to say arc sine. So go here, take trig function, arc sine. We have 17 divided by 39. Remember, I don't have a decimal here, so we need to go control approximate. And so that answer is going to be approximately 28 point, I lost the number. Let's see, 25.8. Let me fix that. So V is approximately 25.8. So 25.8 degrees. So that's V right here. So if that was about 25.8 degrees, remember, to find this angle, all I have to do is go 90 minus 25.8 degrees. Okay. So these right here are just a couple of things to remind you of what, grade. This is a road grade. Road grades. Let's say it had a 12% grade. That's rise over run. Percent means 100, right? 12% is 12 times 1 over 100, which is your rise, 12 over your run, which is 100. Altitude of a balloon. Altitudes are always perpendicular. Keep that in mind. Altitude of 10 feet. So that would be from here to here. An angle of elevation is always an angle that does come up this way. Starts flat with the horizontal. Likewise, the angle of depression is an angle that's going to drop down, okay? Keep in mind, let's say, that's 15 degrees. That angle of depression, one of my favorite things is to show you on this, that if you have an angle of depression, right, which is here's your plane, and your plane's flying along, and it all of a sudden has an angle of depression where it's going down, let's say 15 degrees. Well, this horizontal and this horizontal are actually parallel, which means that if this is 15, so is this. That's also 15 degrees, okay? So it makes sense that my angle of depression is actually the same as my angle of elevation, okay? So keep that in mind. And the sun is 60 degrees above the horizon, so there's your 60 degrees. So it's, again, that's looking up. So the grade of a Pacheco pass is 6%. Find the angle that the road makes with the horizontal. So remember, 6% means 1 over 100. So you have 6%, which is 6 over 100, or 6 over 100. Okay, find the angle that the road makes with the horizontal. So we are looking at that angle right there. Well, I don't have my hypotenuse. We know that that's perpendicular. What you do have is the opposite side and the adjacent side. So that's tangent. So we would say tangent of that angle is equal to the opposite side over the adjacent, which is 100. So theta is equal to arc tangent of 6 over 100. And so I'm going to approximate that. And so I'm going to say, well, arc tangent, so trig function, arc tangent. Okay, that's not what I wanted. Let's delete that. Arc tangent, there it is, okay, of 6 divided by 100 is approximately 3.4 degrees. So it's about 3.4 degrees. So that's the grade of the road right there. That's kind of cool, actually. And lastly, a rhombus that has diagonals length 8 and 12. Keep in mind rhombuses. So if that's 8, this is going to be 4 and 4. And if that's 12, that's 6 and 6. You're trying to find the angle of the rhombus. Well, a couple things about a rhombus, and that is that these angles are congruent. Likewise, the other angles opposite that are congruent. So I only need to find one of these angles. So I'm going to rewrite this. I'm just going to look at one of the angles, which is right here. I know this is 6, and that's 4. I don't have the hypotenuse. I'm not trying to find the hypotenuse. So I'm going to use tangent. So we're going to say tangent of theta, it's always the angle, is equal to the opposite side over the adjacent side. So that's over 6. So tangent is equal to 4 over 6. So theta is equal to move the tangent over to the other side. So arc tangent of 4 over 6. So one of those little angles in there, okay, I'm going to use arc tangent, trig function, arc tangent of 4 divided by 6, and we're going to say approximately 33.7. So we'll say 34 degrees. So I'm going to say it's about 34 degrees, this one little angle here, which is this angle. So if this is 34, that's also 34, which means that this whole angle here is 68. So this angle is 68. So if I were to redraw the rhombus, I would get 68, and that would be 68 also, okay? And keep in mind, it is a rhombus. So that means that the sum of the angles are, because it is four-sided, 360 degrees. So we're going to subtract 68 and get a number, 292, minus 68 again. Oops. 292 minus 68 again, and I get 224, which means the other two angles are 224, which means this is 112 here, 112, and this is also 112. So I hope that helps. We did a lot today. We introduced sine, cosine, and tangent ratios. We learned how to find inverse functions, and using arc sine, arc cosine, and arc tangent, we learned how to use a calculator using those same functions, and also we did a few application problems. So I hope that helps. Thanks for watching, and I'll see you next time.